let's look at number 10. In number 10, we're going to start using equations now. And in number 10, we have an electric current of 1 coulomb per second is equal to 1 ampere. So we're kind of defining what an ampere is. We're creating a new unit here for current. And so the definition of current is an equation that looks like this. Current is written as a capital I, and that equals the flow of charge, Q, per an amount of time, a delta lowercase t, and delta meaning change in, t meaning any amount of time when it's lowercase. So we're looking at the flow of charge in an amount of time. And that's what we call current. And now, if we want to put in the units for these, we could put in 1 coulomb for the unit of charge, 1 second for the unit of time, and that's going to, if we put the rate, to make a ratio out of that or a fraction out of that, then that's going to give us the unit for current, which would be 1 capital A for ampere. Number 11, we're going to actually start doing some math here. They're going to give us some numbers. We have a charge of 5 coulombs, so that coulombs is going to give us our Q moving through a circuit in half a second, 0.5 seconds. So that's going to give us our change in time. Now, how much current? Current is going to be our letter I, is flowing through the circuit. And so this is the equation that we're going to use. I equals Q over T. Now, how did I pick that equation? I looked at what I was given here. I was given a Q, I was given a T, I was given an I. And so I just look for an equation that relates those three things together. And then I do what I call plug and chug. We're going to plug in the numbers, we're going to chug out the answer. And to remember this equation, I remember this phrase, I'm a cutie. Now, I'm not all saying that I'm a cutie. I'm just saying that if you want to remember I equals Q over T, it almost, if you say it really fast, almost sounds like the phrase I'm a cutie. And that's what I use to memorize this equation. Because equations are hard to memorize. If you just try to think I equals Q divided by delta T, too robotic and hard for our brains to latch onto. Now you're going to use this equation for numbers 10 through 16. Let me just walk you through an example of one here. So again, we're going to see 12 is going to use it, 13, 14, 15, and then we get into 16, and then 16 is probably the hardest one, so let me kind of walk you through that. If you can do 16, you can do the rest of them. It says, in the circuit shown, how many coulombs of charge, so we're looking at a Q, will pass through a resistor R in 2.0 seconds, and that's going to be our change in time, our delta T. And then they draw the circuit for us. It's very nice. And so they show that we have a 12-volt source, probably some kind of, some kind of battery there. Now, these batteries are all 1.5 volts, but maybe you chain them together and you get enough of them, you'll get 1.5 plus 1.5 plus 1.5, and you get 12 eventually. So maybe you have a 12-volt source, and it's going to run current. Let's say that maybe this is the positive side of the 12-volt source and this is the negative side. So then conventional current, the flow of positive charge, would flow out of the positive and around to the negative, and we'd write an I for that. And then it would flow through the battery and keep on going around as if the battery were like a pump of electrical water. And then we would say that current would be flowing clockwise in this example. Now we have this little A in a circle here, and that's an ammeter. It doesn't actually use up any of your electrical energy. It's just plugged in there to measure current for us, and it's telling us that we have a current of 3.0 A, 3.0 amperes. And so we have a Q, a T, and an I. Now they give us an extra piece of information, that 12 volts we don't need. So I've written out my equation here, I equals Q over T, I'm a QT, and let's see if we can solve this puzzle together. And so I'm going to take the I, which is 3.0 amps, I'm going to put that in there in place of I, substitution, if you use your math words. Charge we're looking for, so I'm going to leave that alone, I'm going to leave that as a Q. We're going to divide by our change in time, which is 2.0 S, 2.0 seconds. And now we're going to solve for Q as if we were solving for X in math class. So what I'm going to do, if I'm dividing over here on the right by 2.0 seconds, if I multiply both sides by 2.0 seconds, let's see here, squeeze that in over here, 2.0 seconds, that's being multiplied by 3.0 amps, then I'm going to get 6.0, and then our 2 and our seconds on the right cancel, and I'm left with Q. And then what's the unit for Q? The unit is coulombs, and so I'll put a capital C in there. So I'm going to end up with 6.0 coulombs of charge, and hopefully I find that, and yes I do. Right there it is, answer choice B.